Today we're going to be doing transformations and reflections. So you're going to be filling in the blanks about these couple definitions. The first one is congruent figures. The symbol for congruent is an equal sign with a little squiggle above it. That means that they are congruent. But what it means to be congruent, they are geometric figures that have the same size and the same shape. Congruent figures have different orientations, which means it could be a triangle downways, it could be a triangle up. Congruent angles have the same degree measure, and congruent segments are the same length. In cases of congruent polygons are any shape. When you have two vertices, you imply that they are corresponding angles. Vertices, what I mean by that is, let's suppose we have triangle A, B, C. So this is triangle A, B, C, and triangle D, E, F. So here's triangle D, E, F. The vertices are A, B, C. D is a vertice, E is a vertice, and F is a vertice. If these two are congruent, that means that A corresponds with D. And you can look at your congruency statement. A and D are in the same position. B and E are in the same position. C and F are in the same position. So similar figures are figures that have the same shape but are different sizes. The symbol for similarity is two squiggles. Two figures are similar if the lengths of their corresponding sides form a proportion. So let's say that triangle ABC is similar to triangle DEF. That would mean that AB first two over DE would equal BC over EF. And it would also equal first and last AC over first and last DF if you put in their side lengths. A translation describes a function that slides or moves. You can get rid of that. That slides or moves an object a certain distance. In a translation, every point, so every ordered pair, must be moved in the same direction in the same distance. So let's take a look at question number 1. It says the graph of a line is shown below, right here. To find the slope, Andy makes a right triangle B by using the graph of the line as the hypotenuse of his triangle shown. To check his work, he repeats this process and makes right triangle A. Why should the slope of the line be the same when calculated with either triangle? So I said, okay, why should the slope be the same? Well, let's find the slope. Remember, you find the slope with the rise over run. You know that this is positive, so I counted. I went to the right 1, so that's positive 1, and up 2. For triangle A, I went to the right 2, but up 1, 2, 3, 4. So the slopes of triangle B rise 2 over run 1. Triangle A, the slope of the hypotenuse, I'm going to put that on there, would be 4 over 2, which is also 2 over 1. So that tells us about our side lengths. Are the two triangles congruent? No, they are not the same. Congruent means the same size and shape. And they are not. Are they similar? Remember, if triangles are similar, their sides are proportional. Where are their sides proportional? One triangle is a translation. They're not the same size. The lengths of each triangle are equal. They're not equal. They are similar because all of the sides are corresponding. If we did base over base, it'd be 1 over 2. Leg over leg equals 2 over 4. And then we could have used the Pythagorean theorem to find the length of the hypotenuse, and they would have all equaled 1/2. So they are similar. A reflection A transformation in which a geometric figure is reflected across a line, creating a mirror image. That line is called the line of symmetry. I always think about it like the book binding. Let's look at number 2. It says point A prime. Anytime you're creating a new point after some form of transformation, you would call it A prime, B prime, so on and so forth, is the image of point A after reflection across line W. Both points are graphed on the coordinate plane below. Part A says draw a line from A to A prime. Well, that's pretty simple. Just going to draw my line from A to A prime. Part B, find the slope of the line you just drew. So I'm going to use my triangle way with my rise, over, run. So I went, there's my right triangle. And I know I went up 3, right 3, so my slope is 3 over 3, so it's just 1. Line W is the reflection line of A to A prime. Is perpendicular to the line you drew in part A, but in the middle. Draw it on your pictures. So here's my red line. Line W I'm going to go ahead and do in purple. It's perpendicular. So that means that these are all right angles. This is line W. I'm going to put arrowheads on it because it's a line. Part D says, know what you know about perpendicular lines. What is the slope? Remember, perpendicular lines have slopes that are opposite and reciprocal. So it would be, instead of positive 1, negative 1. Because 1 over 1 flipped is just 1 over 1. This one is really cool. Now we're going to do a rotation. A rotation is a transformation of a figure that moves a figure by rotating it around a fixed point. So when we look at 3, it says rotate square ABCD, ABCD, 90 degrees about the origin clockwise. So let's think about what it means. 90 degrees about the origin clockwise. If it creates a 90-degree angle, that's going to tell me that my slopes are perpendicular, because don't perpendicular lines form 90-degree angles? So what I need to do is I need to look at each of the slopes from the origin to the point. So let's find the slope. Write this down because this is important. From origin to the point. So let's do the first one. Let's do origin to A. So I'm just going to call that A. And I went up 2, right 2. So it's 2 over 2. I need a perpendicular slope, so it's opposite reciprocal. So perpendicular to A is going to be opposite negative, but it's going to stay 2 over 2. I'm not going to simplify these because I want it to be equal distance. So I went up 2, right 2. So now I'm going to do the opposite. I'm going to go down 2, right 2. Did I form a 90-degree angle? You can see it because of that perpendicular. And then I'm going to write A prime. Let's do B's. From the origin to B, I went up 1, 2, to the right 1, 2, 3, 4, 5. So it was 2 over 5. The perpendicular slope to B would be negative 5 over 2. So I went up 5, right 5. Now I go down 1, 2, 3, 4, 5, right 1, 2. And I have B prime. And I can see my 90-degree angle right there. Let's do C. C, I went up 1, 2, 3, 4, 5, right 5. So C was 5 over 5. So the perpendicular to C would be negative 5 over 5. So instead of up 5, right 5, I'm going to go down 5, right 5. And that's my C prime. Let's do D. D to the origin. I went up 5, right 2. So I'm going to go from my perpendicular to D, it's going to be negative 2 over 5. So instead of up 5, right 2, I'm going to go down 2, right 5, and I have my D prime. And again, when you do all of these, you can see the right angles that were formed with the origin. Now I'm just going to connect, and I can see my square. So I'm just going to write out the ordered pairs. A was originally 2, 2. B was originally 5, 2. C was originally 5, 5. And D was originally 2, 5. A prime is now 2, -2. B prime is now 2, -5. C prime is now 5, -5. And D prime is now 5, -2. So every time you're doing these, you can see, because it's a 90-degree angle, you're looking at the slope. And it went clockwise. So what did you notice about the slopes? They are perpendicular. And you can really see that. This time it says rotate A, B, C, D 180 degrees counterclockwise. 180 degrees is a straight line. It doesn't matter how the straight line is. It just means it's a straight line. Let's think about the slope of straight lines. Is it going to change? No, it's going to be the same slope. So again, it's about the origin. So I'm going to find the slope from the origin. So from A to A, look at, we can even get all our slopes from number 3 because it's the same square. So the slopes of A was, remember, 2/2. So I'm just going to continue that. So I went up 2, right 2 to keep going. I'd go down 2, left 2. And notice I just continued the line, and there's my A prime. B had a slope of 2/5 from the origin to B. I went up 2, right 5. Now I'm going to go down 2, left 5 to get B prime. C had a slope of 5/5. So it was right here. Now I go down 1, 2, 3, 4, 5, left 1, 2, 3, 4, 5. And there's my C prime. D had a slope of 5/2. Up 5, right 2. Now I'm going to go down 5, left 2 and get my D prime. So that whenever I connect all of them, I can see my square, and if you look at all the lines, they form straight lines connecting with their original ones. And it makes it look like a pretty cool 3D figure, I think. So they had the same slope.